Alright, here are a couple of extra features that are often added to experiments to improve them. Blind and double blind, making your experiment, the way that would be used in a sentence is making your experiment blind, or better yet, double blind, and randomized block design, which usually is just called blocking. But on the test will probably be referred to as randomized block design. Experiments can have these things. They're not necessary. You can create a fine experiment without either one, but often each of these improves things in the right context. So let's talk about blind and double blind. Let's say I want to see whether a weight loss drug does indeed reduce people's weight. If I grab 40 people and give 20 of them, randomly chosen, 20 of them the actual weight loss drug, and 20 of them I give nothing, and I say, I want to see how you do in another 3 months, and then send them out with the drug or without the drug, half of them know they're getting treated with the weight loss drug. This may affect their psychology as to whether they will bother going jogging in the morning. It might make them less likely to want to bother exercise considering they're getting a treatment. Anyway, it might have the opposite effect. We don't know. But because they know they are getting the drug, that may affect their behavior. And so by making the experiment blind, that refers to making them not know whether they're getting the treatment. So what you do is you bring in your 40 people, you give all 40 people a pill, a pill to take, and then they go home and they take the pill, but all of them are told the same thing, either that they're all getting a weight loss drug, or that they may be getting a weight loss drug, but might be just getting a useless sugar pill. The taste is the same. And so they don't know what they're getting. That makes them blind as to what treatment they have received, and that means that they won't have the confounding variable of their own mentality affecting their behaviors. Double blind refers to when even the experimenter doesn't know who is and who isn't. Now, of course, the person running the experiment has to know the results, but they can hire someone else to actually give out the pills. So, for example, if I'm the researcher trying to research this, I will hire an assistant, and I will tell the assistant, I've marked these bottles 1 through 40 for the 40 subjects. Give each person their bottle and tell them to take it home. And then my assistant hands out these pills to each person, not knowing for each person whether they're getting the sugar pill or the actual drug. And that way, and then when the people come back in to be measured after 3 months, I tell that person who doesn't know who's getting what to measure their weights on the scale, so that this experimenter, if they round up, they'll round up the same way for everybody. They aren't going to know who got the weight loss drug. When the person gathering the data doesn't know who's in which group, that makes it double blind because the experimenter doesn't know either. It doesn't affect their psychology when measuring the results. Now, this is an improvement to any experiment if it's possible, but it's not always possible. For example, let's say I decided to see if activity in sports improves someone's grades. Well, the people who are told to do sports know they're doing sports. There's no way to avoid that. That doesn't mean you can't run an experiment because you can't make it blind or double blind. It just means that you can't add that extra good feature to the experiment. The people who are told to do sports know they're being told to do sports. The people who are told not to do sports know they're being told not to do sports. So, yeah, it's not always possible. Another thing that sometimes is handy is randomized block design, which is when let's take a look at the example of whether sports cause people's grade to go up. So I gather my 40 students and I randomly pick 20 of them to do sports. But what if by bad luck I end up grabbing 20 people who already do sports and tell them to do sports? Isn't it possible that would be a confounding variable that would mess up my results? Now, it's unlikely that the 20 I pick will all happen to be one thing, but by blocking, I will remove one more possibly confounding variable from adding variability, not bias, to the study. So let's say I have, among my 20 subjects, let's make it smaller so it's more manageable. Let's say we have 8 people who absolutely do sports already, and then I have 12 people who don't already do sports, and these are the people who I have found to do my study on whether doing sports causes you to get better grades. So one way to do things, a completely randomized design, totally just random, is to randomly pick half of them, assume this is random, randomly pick half of them to do sports and half of them not do sports. So I turn to these 10 people and I say, you guys are forbidden from doing sports. And I turn to these 10 people and I say, you guys must do sports. So these people, they're going to be happy. It might affect people who already do sports very differently from people who don't already do sports. We might find that the people who are told to do sports who don't normally do sports, their grades go down. And people who do sports, when they're told not to do sports, their grades go down. It might be that it affects one group of the population differently from the other group of the population. So what a blocking design does, what a randomized block design does, is you find something that you think might affect, you find a group of people in your sample who you think might be affected differently by the treatments than the other group. And then you separate them and you do the study totally separately on them from the others. So in this example, you grab your sample of 20 and you notice 8 of them do sports. Man, being told to do sports is going to affect them totally differently from the other group. So you remove those 8 people from this sample, you take those 8 people aside over here. That's the 2 blocks. You have the block that don't already do sports, and you have the block that do already do sports. And the reason you separate them specifically is because you think that the treatment that you're planning to do, forcing some people to play sports, forcing other people to not play sports, will affect those 2 groups differently. And then you run the experiment separately on each of your 2 or more blocks. This block, well, you have 12 people in this block, so you split them into 2 groups of 6. This group you tell you must exercise, you must participate in sports. This group you say you must not participate in sports. This group of 8, you split them 4 and 4, randomly assigned to treatments. Then you say, you 4 must do sports, you 4 must not do sports. Then you can study the effect separately on this group and that group. If it doesn't make a difference, if sports improves the results for both groups, then you can say sports, improves for both. But if it only improves for one of the groups, you'll be able to see that. And that's the purpose of blocking, to notice effects on subpopulations. And the reason you would do this beforehand, instead of just, seeing what your results are and then blocking after the fact, is because that way you can make sure you have 2 equal groups, both of reasonably large size. Because if you start blocking after the fact, you're like, whoa, those 2 people who love eating ice cream, playing sports really improved their grades and didn't do anything. Well, at that point, if you're looking for at subgroups after the fact, you're very likely to notice things that aren't actually related, but that appear to be related because of variability, just due to a random chance. If you block ahead of time, it's more intellectually honest. Right? You always block based on something that you think is going to make a difference in the results. One group you think will be affected differently by the treatments than the other group, so you separate one group from the other. You run the study parallel for both groups, or for more than 2 groups. You can do it for 5 groups if you want to. There's times when you won't want to block, because there is no thing that's relevant that you think will affect them. For example, if I want to study whether a pill will have a different, whether this pill will cause people to lose weight, is there any reason is there anything, would I want to separate those who do sports from those who don't do sports? maybe, but maybe not. You only do blocking when you think that one group will be affected differently by the treatment than the other.